Good evening, everyone, or good afternoon, as Brian says. My name is Isabella, and I am a rising junior at Homestead High School. And my project is the solar tracker. As you can probably tell by the name, my project basically has a solar panel that will move to where it detects the most light, and it also just measures different values and prints it out on this display module that I have in the front, as well as absorb just solar energy and use it for a smartphone charging port. And I chose this project because I was just really interested in solar energy, and I wanted to just learn about the relations of like solar energy and just engineering, and as well as just how to use software and hardware part components together. Um, yeah, here's a quick demo. Okay, as you can see, this solar panel starts off at its initial position, and it will move up because right now the most light that's in this room is coming from these ceiling lights, so that's why this solar panel is moving up. And in this video, I will show another example where I will just be shining a flashlight on it, so the solar panel will move based on where this flashlight is. And as I was mentioning before, the display panel basically will show many different values that I have. For example, the light value, which is how much light is being detected by the solar panel, as well as the temperature and humidity values, which are basically measured by the temperature and humidity sensor, as well as one of my modifications, which I decided to add a voltage sensor to. So I could basically measure the voltage of the batteries. And if you can see here, the display module is very small. So because I had all of these values that I measured, I wasn't able to just display them all onto that one panel because, well, it was too much and it was just 2 lines of text. So I decided that I would also implement another one of my modifications, which is basically just using a Bluetooth module and connecting my solar tracker to a mobile app. And that way I could use the mobile app to control like what I can see and what I can't, which I will be showing. So as you can see here, there's a light that is being flashed onto the solar panel, and the solar panel will move based on where the light is hitting it. And on the top right corner, this is the mobile app I'm using, and it's called like some Bluetooth terminal thing. And so, sorry, when I press 0, it will basically show at the bottom the light values and temperature and stuff. And as you can see, when I type 1, it will switch to a different display, which currently right now at the bottom, it will show the display for the voltage. And yeah, okay, so for how this works, the solar panel, basically, the angle I calculate is from 4 photoresistor sensors, which I put on the 4 sides of my acrylic panel. And these photoresistors basically measure the light intensity value it has, which is basically how much brightness of light it measures. And using these 4 different values, I'm able to use some simple trigonometry to determine 2 angles for how the solar panel will move. And as the solar panel moves, it absorbs basically solar energy, which I then use a lithium power module to basically turn that solar energy into electrical energy and then store that in these batteries, which then can be used to charge a smartphone. And so for some challenges I had, first, I really struggled with the movement of my solar panel. For one, it was just the math was pretty difficult, so that took me a bit. But also, at the start, when I first had my motors, it was just really unsteady, and it was just like wobbling a lot. So you can't really see how it moved, and it was just very inaccurate, and all of it was very messy. So I first tried to tackle that problem using software, and I basically implemented a different library. And this library will basically, it's called servo easing, and it helped me, it helped me just control the speed of the servos a lot easier, and I was able to just control the servos in general with like a lot simpler code. But when I did that, it did help a little, but it wasn't very helpful in that sense. So I switched to doing a hardware tackle, and I basically replaced my old mount, as you can see, with this new one, which is bright orange. And this mount has a higher like circle here, so it basically helps with just like making sure it doesn't go all over the place and just stays in place. And another challenge that I had was because my voltage sensor, which was one of my modifications, used the same pin as my photoresistor. So basically, I wanted to have both the data being collected, but I only had one pin. So in order to combat that, I used two transistors to be able to just digitally switch between both of them and just constantly collect data from both. And for some next steps, I would definitely try making my own app instead of using this app that's already been given, because I would I would just try to add like more functions that could help maybe the user have more freedom with this solar tracker. And um, for things I learned in Bluestamp, well, first off, I learned about the C++ language because I've never used that in the past, and that was pretty fascinating. And I also learned about just like different hardware components because I've never done anything really related to hardware before. So like skills like soldering and like different wires and sensors. Thank you. Um, I'm not really sure about that, but I do know that it's enough that you can still see it. It's not like this. So besides that, I feel like if you change it to a bigger scale, you could have many things like at-home appliances, like powering maybe light sources, having more renewable energy sources, or you can have something like an off-grid area which doesn't have much reliable energy, and that way you can have something like a solar tracker that can help power like maybe smaller appliances that they might.
There are so many components in the system. Can you tell a little bit how you program the components?
Yeah, so there may be a lot of components, but actually using them isn't, I don't think it's too bad.